In this video, I'm going to go through the solution to Big Bang, encoding and decoding. This example is concentrating on decoding the message. Let's say the message is FXAB and the key is 3. Let's see how I'm going to go about solving this problem. The first thing I'm going to do is that for every character of the decoded message, I'm going to find the location in alphabet. The alphabet, I have shown it here, all in uppercase. So for F, the location of F is 246 in the alphabet. X is here, which is 24. A is the first character, so the location is 1. And then B is the second character. Now, the next thing I'm going to do is to find the shift. The formula for shift is 3 times position plus 3, because F is the first character, so it's 3 times 1, which is 3 plus 3 is 6. X is the second character, so 2 times 3 is 6, plus 3 is 9. And then as you can see that each one of them is incremented by 3. So these are the shifts. The next thing I'm going to do is I'm going to subtract the location in alphabet and the shift. So 6 minus 6 is 0, 24 minus 9 is 15, 1 minus 12 is negative 11, 2 minus 15 is negative 13. Then I'm going to look at the I value. If the I value is less than or equal to 0, I automatically add 26 to it. So 26 plus 0 is 26. 15 is not less than or equal to 0, so 15 is not changed. 15 stays 15. Negative 11 is less than 0, so 26 is added to negative 11, I get 15, and 26 is added to negative 13 because it's a negative number, it becomes 13. Then these are the decoded locations. I'm going to find the character corresponding to these locations. For instance, character corresponding to location 26 is here, which is Z. Z. Character corresponding to location 15. 2, 4, 6, 8, 10, 12, 14, 15 is O. So it's O. Again, we have O. And for 13, we have 2, 4, 6, 8, 10, 12, 13. So this means that when the encoded message FXAB is given to our app, it has to display zoom. Now the next example, if the input to our app is JTUSUKG and the key is 5, then we are going to do the same thing. We are going to find the location of every one of these characters in our alphabet here. J is going to be 10. For T is going to be 20, and so forth for all of them. Now we are going to find the shift. Remember, the shift is 3 times the position, so J is position 1 in this string, so it's 1 times 3 is 3, plus the key, which is 5, which is 8. Then the next one is T. T here is the position 2 times 3 is 6, plus 5 is 11. You can see the increment is always 3. So the next one is 14, 17, 20, 23, 26. Now we have to find I. Remember, I is location in alphabet minus shift. So 10 minus 8 is 2, 20 minus 11 is 9, 21 minus 14 is 7, and so forth. These are the numbers. Now, the decoded location, if I is greater than 0, then it's going to be the same value. So I is 2, 9, 9, 7, 7, 2211, but when I become 0 or less than 0, we add 26 to it. So 26 minus 12 is 14, 26 minus 19 is 7. Now we are going to find the character corresponding to this location. Location 2 is B here. So B is the decoded character. Location 9 is I, which is here. Character 9. 2, 4, 6, 8, 9. I. 7 is G, which is here. And then the next one is 2, which is B, and so forth. So we get Big Bang. Now we are going to write the same code here. So start your MIT App Inventor, create a new project. Let's call it Decoder App. Change the title, add a horizontal layout, and then a label. Change the text to enter a text, then add a text box. I have set the name of the text box to be input underscore txt, then add another horizontal layout and drag and drop a label, put the text, enter key, and then another text box, and this time I've set this one to key underscore txt, then also a button here, I call it decode underscore btn, and also I have added a notifier so I can use to display a message to the user. That's about the design. And then initially I'm going to set the value to 0. The next one, I'm going to introduce a new variable. Let's call it return value, and I'm going to set the initial value to 0. Another variable I'm going to introduce is input, and then set the initial value to blank. The next one I'm going to introduce is output, and the initial value to blank. The next one I'm going to introduce is, let's call it alphabet, and the values that I'm going to put here are the alphabets here: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U. So these are my alphabets here, and that's it. These are all the variables I'm going to introduce at the moment. A procedure, a part of the code that is going to be repeated. So when I click on the procedures, I have two different blocks here. This block does not return anything. It just processes something and then it comes back. This one does that process, but it also returns a value for me. I am going to use this type of procedure, and I'm going to call this one a name. I call it get underscore character index. What this one does is that when I give a character to this procedure, it's going to return the index inside the alphabet. For instance, if I give this procedure character A, it's going to return 1 here because this is the index of character A. So this means that this guy has to get an input. To get the input, I just click on this part, and then I want an input, so I just put it inside. and you can see that this one is added. The name is X, which is not a nice name. I'm going to call it char, character. So this means that if I called get underscore character index with a supplied character here, it's going to return the character for me. Now, how do you return something? You go to control. You see this block which says do result. This means do this part, this inside here, and then return something here. Now, what I'm going to do is that I'm going to go through every character here, and I'm going to check to see if that character is equal to supplied character. If it is, then I'm going to return the index. To do that one, I need to go through a loop. So I'm going to say for each here, and I'm going to change this one to index, and I'm going to go from the first character to the last one. The last one, I'm going to say the length of alphabet. So I'm going to take this one out. I'm going to go to this, and then I'm going to bring this one down, and then I want the alphabet. So I'm going to go to alphabet here and get alphabet. So I'm going to start from the first character to the last character, character by character, because the increment is 1, and I'm going to check to see if the character at the position index is equal to this character. To do that one, I'm going to go and I'm going to say an if here, put it right here, and I'm going to say if compare text is equal to. Now I need to find the character at index position here. So I need to go here and I need to get this segment. So I'm going to say the segment of text. The text is global alphabet. The start is the index and the length is 1. I'm going to say if this character is equal to this character that I have given, then I know that the return index, the return value, I'm going to set the value here to be equal to the index. So again, this procedure, given this character, is going to go through every character of alphabet, and then it's going to return to me the index of the position. And what I'm going to return, I'm going to return the return value. So I go up, or I just copy this one, put it here, and then change this one to return value. So this one is the one that I'm going to call twice for every character. Now I'm going to go and I'm going to say if my decode button is clicked, and I'm going to write the code now. The first thing I'm going to do is that I'm going to change the input to uppercase. So I'm going to go and I'm going to set the input to uppercase of whatever the user enters. So I'm going to say the uppercase of the input text. So this way, I'm going to make sure that the input is in uppercase. The next thing I'm going to do is that I'm going to use the output variable I introduced here to have the decoded message. So I need a duplicate of this. I don't need this one anymore. And I'm going to change this one to output, and I'm going to set the value to be blank. This means that every time the user uses the app, the output starts initially with blank. Now I'm going to go through a loop. I'm going to go through a loop, and the index, I'm going to call it position. Any name you want, doesn't matter. So I'm going to start from the first character. Obviously, here, again, I'm going to go through the length. But this one is going to be the input. So I'm going to go through every character one by one. And now I'm going to find, now I have to find the value of I. If you remember here, the value of I is the location of the character in the alphabet minus the value of the shift. So I'm going to set the value of I here. I don't need this one. I'm going to change this one to I. So the value of I is the location of the character in the alphabet. Now I'm going to use that procedure that I created, which is this one, get character index. And the character is going to be the character at the position of the input. So I need to use mid segment. So the text is going to be my input text. So I need the input, and the start is going to be my position. So my position, and the length is going to be 1. I need here. So this is the character that this procedure is going to return the index of. Now, I have to use the formula again. Go back here. You will see the formula says the location minus the shift. So I have to find the shift now. So I need a subtraction operator. So I go up and I bring a subtraction here. Now, one thing you have to know that this block has another form which is much easier when you have a long line of code. If you right click and click on external inputs, you will see that the inputs now are going to be vertical here, which is easier for us right now to write the code. So the code says global I is the position minus shift minus the shift, but the shift is 3 times position, so I need a multiplication 1, and then it's going to be added to the key that the user enters. So I need an addition to. Now 3 times, so this is duplicate here. I'm going to change this one to 3 times position. Position is coming from here, and then add to it the value of the key, and the key is here, and this is text. Now I can add it here. So again, your I is going to be your position of the character in the alphabet minus the shift, which is 3 times position of the character plus the key value. This is your I. Now the point is here to check to see if I is negative or equal to 0. So I need an if condition. So I'm going to get one of these blocks and I'm going to say less than or equal to 0. So I'm going to say if global I. So I'm going to get this one. I'm going to say if global I is less than or equal to 0, then I'm going to add 26 to my value here. So I'm going to say I need a global here again. So I'm going to bring here, change this one to I, take this one out. Now I need an addition here. And then again, I'm going to duplicate this one, make this one I, and then 26 here. Everything is done with I. Now I have to see what character corresponds to this value of I. And then I'm going to append it to my output. So I'm going to say set here, duplicate. So I'm going to say set output, because I have to join them together, appended. So I'm going to say join the previous value of output, and then I'm going to add the character which corresponds to this I position. So I'm going to use the segment one. The segment one is going to be, instead of this get input, I need the alphabet, and the position is my I value now, and the length is 1. Then this is going to add the new decoded character to my output. And the last thing I need to do is to use the notifier and show the result of decoding the message. So when I'm done here, after the loop is done, I have to show this message. So I need the text, the title, I'm going to call it Decoder App. The button, I'm going to say OK, and the text is going to be output. Okay, now we can go ahead and check the app. I've already started the emulator, so let's go to emulator and start entering the values. The first one, let's say we enter FXAB and the key is 3. Let's see what we get. Gives us a zoom. This is what we are supposed to find. The last test, let's enter ics2o0 and the key is 5. Let's see what we get. We get Big Bang.